In question 1, we have triangle NCB, which we should draw. And it tells us the measure of angle N is 5 more than twice the measure of angle C. And we get to the comma, so we should stop reading. The measure of angle C comes at the end of that part of the sentence, so we're going to call that X. And 5 more than twice X is translated as 2X plus 5. Notice these are angles, so we're putting the expressions in the mouths of the angles and not on the sides. And the measure of angle B is 35 less than 3 times the measure of angle C. So we can translate that as 3x minus 35. We're being asked to find the measures of each of the angles in the triangle and to determine what type of triangle this is. So we know all the angles in a triangle add up to 180 degrees. So we can write x plus 2x plus 5 plus 3x minus 35 equals 180. Combining like terms, we get 6x minus 30 equals 180. Adding 30 to both sides, we get 6x equals 210. Divided by 6. And x is equal to, let's see, 21 divided by 6 3 times. 3 times 6 is 18. 30 divided by 6 is 5. So x is 35. That is not the answer to the question. We want to find each of the angles. Angle C happens to be 35 degrees. Angle N would be 2 times 35 plus 5, which is 75 degrees. And angle B is 3 times 35 minus 35, which happens to be 70 degrees. So the angles are 70, 75, and 35. And therefore, this triangle, we can say, is acute because all of the angles are acute. And we can also say it's scalene because none of the angles are equal. So it's an acute scalene triangle. Question 2. We have triangle ABC. And the measure of angle B is 8 times the measure of angle A. So the measure of angle A is x. And B is 8 times that. So that's 8x. And the measure of angle C is the sum of the measures of angles A and B. Sum means to add. So if we took the measure of angle A, which is x, and added it to the measure of angle B, which is 8x, remember there's a 1 in front of an x, the sum of these things is 9x. And again, we're working with all the angles of a triangle. So all 3 angles of the triangle, add up to 180 degrees. So we have x plus 8x plus 9x equals 180. As we noticed, the question is asking us to find out what type of triangle this is. We would need to know what the angles actually are. So we can solve this equation for x and then figure out what the angles are. So we get 1 plus 8 plus 9, which is 18x equals 180, divided by 18. X is 10, and x is not good enough. We can't stop there. Angle A is x, so that's 10. Angle B is 8 times x, or 8 times 10, which is 80. And angle C is 9 times x, or 9 times 10, which is 90. So we have 3 angles. None of them are equal, so the triangle is scalene. And one of the angles is a right angle, angle C. Even though the picture doesn't look like it, it turns out that it was a right angle. So we can call this a right triangle. So the triangle is right and scalene. Number 3, the perimeter of triangle DEF is 42. And angle D is congruent to angle F. If angle D is congruent to angle F, that means we have an isosceles triangle, which means E is the vertex angle. And it also means that across from angle D, side EF is congruent from the side across angle F, which is DE. So we have 2 congruent sides now. We're told that DF, side DF, 2 letters, is 6 less than twice side DE. So since DE comes at the end of the sentence, mark it as x. And DE is a side length, it's 2 letters. And DF is 6 less than twice that. Translates to 2x minus 6. But also, notice DE and EF are congruent. So since DE is the length of DE rather is x, so is the length of EF. We knew the perimeter was 42. So we can now add up the 3 sides and get 42. Notice they don't add up to 180 because they're not angles. So we have x plus 2x minus 6 equals 42. Combining like terms, we get 4x minus 6 equals 42. 4x equals 48. X is 12. We were asked to find the lengths of the sides of the triangle. So DE and EF are equivalent to x, so DE is 12. EF is also 12. And DF is 2 times 12 minus 6, which is 24 minus 6, which is 18. So the side lengths, I need 3 answers because there are 3 sides of the triangle, are 12, 12, and 18. Number 4, the measures of, and I want to insert something here, of each of the base angles of an isosceles triangle are 9 degrees less than 4 times the vertex angle. So we need to draw an isosceles triangle. We have our base angles, which are equal, and our vertex angle. The base angles are each 9 less than 4 times the vertex angle. The vertex angle is coming at the end of the sentence, so that's our x. And translating 9 less than 4 times x, it goes backwards. You start off with the 4x and subtract 9. We want to find the measure of each angle of the triangle. So again, we have 3 angles in a triangle. All 3 add up to 180 degrees. We can do that because they're all angles inside the triangle. X plus 4x is 9x, minus 18 is 180. Add 18 to both sides. We get 9x is 198. Divide by 9. X turns out to be 22. And again, that's nice, but we also want to find out the measure of each angle of the triangle. So x is 22. So that's this angle up here. 4 times 22 minus 9 would be each of the base angles, which turns out to be 79. So the measure of the angles of the triangle are 22, 79, and 79. Next question. It says to find the measure of angle ACB in the diagram below. We learned on Thursday in class that the 2 interior angles far away from the exterior actually end up adding up to the exterior. So we can take 8x plus 20 and add them, and that equals x squared. So now, as I explained in class, x squared is like a celebrity, and everyone needs to be moved over to his side in an equation like this. So we subtract the 8x and subtract 20. We get 0 equals x squared minus 8x minus 20. And this is all algebra from last year. This needs to be factored, and it factors into x minus 10 and x plus 2. Setting each factor equal to 0, we get x equals 10 and x equals negative 2. We have to reject the negative solution because this is a geometry problem. X cannot be negative because that would force, say, for example, angle B to be negative 16 degrees, which is unacceptable. So we were asked to find the measure of angle ACB. ACB is the interior angle here. So if you notice, we don't have an expression of x written there, but we can form linear pairs here, a rainbow right there. So if we get x squared, we could subtract that from 180. So that's what we'll do. X squared is 10 squared, which is 100. 180 minus 100 is 80. So this angle, the interior angle, is 80. Now it says, so let me just write that. Measure of angle ACB is 80. It then says, are there two line segments which are congruent? So if we take a look, are there two line segments which are congruent? We have a triangle ABC, and if you notice, if I plugged in the x into the top here for angle B, 8 times 10 is 80. If you notice, this triangle is an isosceles triangle. I'll redraw it over here. This is where we need to be careful. This triangle is isosceles. Angles B and C are the equal angles, and angle A is the odd man out. So in fact, since we have an isosceles triangle, there are two line segments which are congruent, going across from the equal angles. So we can say AB is congruent to AC because in an isosceles triangle, sides opposite the base angles are congruent. So there are two sides which are congruent, and we've explained our reasoning.